shall deal with thermochemistry, part of thermodynamics. Under thermochemistry, we deal with heats of reactions, and factors influencing the heats of the reactions and applications of Hess law. So mainly we will concentrate on the calculations of delta H and delta E. So what is heat of reaction? What is the heat of reaction? The amount of heat evolved during a chemical process when the reactants undergo complete transformation as given in the balanced chemical equation. As given in the balanced chemical equation. What are the factors that influence the heat of the reaction? 1. Temperature, 2. mass, and 3. conditions at which the chemical process is carried out. So if the process is carried out at a constant pressure, heat of reaction Q is equal to delta H. What is Q? The amount of heat evolved or absorbed during a chemical process. When the reaction is carried out at constant pressure, Q will be equal to delta H. When the reaction is carried out at constant volume, Q will be equal to delta E. What is the relation between delta H and delta E? Delta H is equal to delta E plus P delta V, or delta H is equal to delta E plus RT delta N. Now here what is the other important point to be remembered? Heat of formation of a compound will be equal to enthalpy of the compound. Why it is so? Because the enthalpies of the elements at standard conditions are taken as 0. Now what is when bond energies are given, what will be the heat of the reaction? Heat of the reaction will be equal to sum of bond energies of the reactants minus sum of bond energies of the products. When heat of combustion values are given, how do you write the heat of the reaction? Sum of the heat of combustion values of reactants minus heat of combustion values of the products. When heats of formations are given, how do you write heat of the reaction? Sum of the heats of enthalpies of the products minus enthalpies of the reactants. What is enthalpy? Enthalpy and heat of formation are one and the same. Now basically the numericals in thermochemistry are types of the heats of the reaction are applications of Hess law. What is Hess law? The net heat change in a chemical process remains the same whether the process is carried out in one step or in multiple steps. So let us discuss the concepts through the numericals. So first, what are the types of the heats of reactions? Heat of formation, heat of combustion, heat of neutralization, heat of hydration, heat of solution. We will discuss those types of the heats of the reactions and the important points regarding the heats of the reactions through the numericals. Let us begin with the discussion through the question. Now what is given here? N2 plus 3H2 gives us to 2NH3. Delta H is equal to minus 46 kilocalories. And what is the question? Heat of formation of ammonia. So how do you define heat of formation of ammonia? Heat of formation of ammonia means the amount of heat absorbed or evolved, or simply enthalpy change during the formation of 1 mole of ammonia from its elements. That is, what are the constituent elements? Nitrogen and hydrogen. But in the given problem, for 2 moles, during the formation of 2 moles, what is the amount of heat evolved? 46 kilocalories. 46 kilocalories. For 1 mole of ammonia, what will be the amount of heat evolved? Nothing but 23 kilocalories. 23 kilocalories. So minus 23 kilocalories. Because since the process is exothermic, delta H takes a negative sign.